So in our last class, we have started the subnetting concept. Subnetting, it is used to, okay, it is used to, just one second. Okay, so subnetting is used to minimize the wastage of IP addresses. What it will do, it will divide one network into multiple smaller logical networks. So we have seen this example of marketing, account, sales, and HR department. And we can perform the subnetting in two ways, FLSM and VLSM. When the requirement is fixed, we perform FLSM. When the requirement is not fixed, we perform VLSM. Okay. And now, guys, what actually we do in subnetting, we need to understand. So we understood, okay, what is subnetting here? We are dividing one single network into multiple smaller networks to avoid or to minimize the wastage of IP addresses. So what actually we do? Let us try to understand. So guys, we convert the host bits into network bits. So what we do in subnetting, we convert the host bits into network bits, or we reduce the number of host bits. So guys, we'll try to understand this sentence. What does it mean by converting the host bits into network bits? What does it mean by reducing the number of host bits? Using this example, imagine our requirement is like 50 IPs. We need 50 IPs. So can we get 50 IPs in class C? Guys, can we get 50 IPs in class C or not? In class C,
Yes,
how
we
many
can.
IP addresses we can get? 256, right?
256.
So 50 IP addresses, okay, we can easily get with class C.
Yes.
So what is the default subnet mask of class C?
255, or 0.
So we'll take this default subnet mask of class C, which is having three network portions and one host portion. 255.255.255.0 is the default subnet mask of class C. Then guys, we will convert this decimal subnet mask into binary subnet mask. So if you convert 255 into binary numbers, if you remember, we will get 8 ones. Remember this point?
Yes.
255 you can see. You will get how many ones? 8 ones.
8 ones.
Then 255, 8 ones. Then 255, 8 ones. And 0 will be 8 zeros, right? Now what we do? So guys, where is this 50 falling? Where is this requirement falling in 2 power table?
2 power 6.
Power 6, right? So how many zeros we have? Currently, how
8
many
zeros.
zeros are there? 8 zeros. And our requirement is falling at 2 power 6. So what we do? Out of these 8 zeros, we will keep 6 zeros because our requirement is falling at 2 power 6. We will keep 6 zeros and remaining zeros will be converted to ones. So guys, what we are doing is subnetting. We are converting host bits means zeros.
Zeros.
Okay,
Zeros to
network
1.
bits means ones. So we have converted zeros to ones or not?
Yes.
Okay, we have reduced the number of host bits or not? Previously we had how many zeros? 8. Now after the conversion, how many zeros we have?
6.
6. So we have reduced the number of zeros or not?
Yes.
So this is what we do in subnetting. Let us take another example. Let us say this time our requirement is 30 IPs. So again, we can go with class C. This is the decimal subnet mask, and we have converted this decimal subnet mask into binary subnet mask. We have already seen this example, just ignore it. Now, how many zeros we have now? 8 zeros. And where is this our requirement falling in 2 power table?
5.
2 power 5.
5.
So we'll keep 5 zeros out of 8 zeros. We'll keep 5 zeros. And how many zeros we are converting here? 3.
3.
3 to 1. So we convert the host bits into network bits. We reduce the number of host bits. Let us take another example. Let us say it is also done. Now let us say this time our requirement is like 12 IPs. Okay, so we are having 8 zeros. Where is this 12 falling in 2 power table? where we
4.
can get 4, 2 4, right?
4.
So out of 8 zeros, we will keep 4 zeros. Remaining zeros will be converted to 1. So we convert the host bits into network bits. We reduce the number of host bits in subnetting. Then guys, let us see the FLSM examples. So as we have discussed, we can perform the subnetting in two ways, FLSM and VLSM. Okay, so in FLSM, we will do, we will see the class C, class B and class A example, and we are not going to cover VLSM. Okay, so let us see the class C FLSM example 1. First, we'll see how to perform the subnetting. So guys, just try to learn the things. You don't need to do any calculations here. I will show you the shortcut also. I'm just trying to show you uh, how this subnetting works. Okay, what is the logic behind the subnetting? First, we'll see what is the logic behind the subnetting using by doing the manual subnetting. After that, we have a shortcut as well. So we don't need to do the manual subnetting. We can use the shortcut method. So let us see how to do the subnetting manually. So guys, we need to follow 5 steps here. Okay, 5 steps. So just remember these steps. What is the first step here? The first step is to check the requirement. We need to check how many IPs we need. So guys, here if you see, what is the requirement?
40.
40.
40. This is our first step you can say. And where we can get, in which class we can get this 40 IP? Can we get the IPs, 40 IPs in class C?
Yes.
Yes, the class is also selected. Very simple. Okay. And we will further simplify it. Now, what is the second step? The second step is, okay guys, so before moving forward, there are two s- simple formulas you need to remember for subnetting. The first formula is to calculate the number of valid IP addresses. The formula is 2 power h minus 2. Guys, what is the formula to calculate the valid IP addresses?
2 power h minus 2.
2 power h minus. So why we are subtracting 2 here?
2 power
Why? Pardon?
2 value.
The network and the broadcast.
Network ID and broadcast ID. If you remember, we don't use the first and last IP address. Okay, except the first and last IP address, all the IP addresses are valid IP address. Remember that concept? So we
Yes.
are
Yes.
subtracting the network ID and broadcast ID. So the first formula you need to remember is to calculate the valid host. If you want, you can write it down. What is the formula to calculate the valid host? 2 power h minus 2. This is the first formula. The second formula you need to remember is how to calculate the number of subnets. Okay, again, the second formula is simpler than this formula. Number of subnets, 2 power n. Okay, what is the formula to calculate the number of subnets?
2 power
2 power n. What is the formula to calculate the valid IP addresses?
2 power h minus 2.
2 power h minus 2. So guys, we are good to go. So our second step is to calculate the number of valid hosts. And this is the formula, 2 power h minus 2. The question is, how will you get 2 power h? Again, guys, you need to check the 2 power table to get the 2 power h value. Where is this 40 requirement falling in 2 power table?
6.
2 power 6. So guys,
6.
2 power 6 is our 2 power h. So we'll apply 2 power 6 to the formula 2 power 6 minus 2, 64 minus 2, and we will get 62 valid IP addresses. And it should be greater than and equal to our requirement. So guys, 62 valid IP addresses, is it greater than our requirement or not?
Yes.
Okay, so we can go with 2 power 6. This is our second step. And guys, the third step, we need to calculate the subnet mask for 40 requirement. So guys, it is mandatory to calculate the subnet mask, a separate subnet mask for 40 requirement. We cannot use the default subnet mask. Okay, we cannot use the default subnet mask after doing the subnetting. Okay, subnetting is all about having a separate subnet mask for the requirement here. Okay, if you do not have the separate subnet mask, okay, let us say you will use this default subnet mask. What will happen? Okay, there is no use of subnetting. All the four departments, they will communicate with each other. What is our requirement here? We need to divide one single network into multiple smaller network, and all the four networks should not communicate with each other. How they will not communicate with each other? After having a separate subnet mask. If you are using the default subnet mask, okay, which means we have not done the subnetting here. Remember this point. So we need, the third step is very important. We need to have the separate subnet mask for the 40 requirement, not the default subnet mask. So what we will do to calculate the separate subnet mask for our 40 requirement, we need to take the default subnet mask first of class C. In our first step, we have selected the class C. Okay. So the default subnet mask is 255.255.255.0. And just give me 1 minute, guys. I'm just coming back. Just give me. All right, guys. So you will take the default subnet mask. After taking the default subnet mask, we will convert this decimal subnet mask into binary subnet mask. 255 8 ones, 255 8 ones, 255 8 ones, and 0 will be 8 zeros. And guys, our requirement 40 requirement is falling at 2 power 6. Okay, it is falling at 2 power 6. So we will keep 6 zeros, remaining zeros will be converted to ones. We have got the new binary subnet mask. After that, we will convert this new binary subnet mask into decimal subnet mask. 8 ones, 255, 8 ones, 255, 8 ones, 255, 2 ones, and 6 zeros, it will be 192. And this subnet mask, guys, okay, this is the new subnet mask, and this subnet mask will avoid all the four different subnets to communicate with each other. You will use the new subnet mask for all the subnets. Okay. After doing subnetting, if you use the default subnet mask, again they will communicate with each other, which means there is no subnetting done. Okay. This is the third step. After calculating the subnet mask, we need to calculate how many subnets we get. So guys, what we are doing in subnetting, we are dividing one single network into multiple smaller networks, but we don't know how many subnets we are going to get. We need to calculate it. What is the formula to calculate the number of subnets? We have just seen the formula. Pardon?
2 power n.
2 power n. 2 power n, and where you will get this n value? The number of converted bits. How many bits we have converted, guys?
2 bits.
2 bits. So our 2 power n is 2 here, and we will get 4 subnets, which means we will divide one network into 4 smaller networks, and each subnet, okay, we will get 64 IP addresses in each subnet. All right. After that, we need to write the range. What is the last step here? We need to write the range of all the 4 subnets. So guys, in our first step, we have selected class C. So we will take any network from class C. Let us say 192.168.1.0 network we have taken, and 1.0, okay, 0 is the network ID of first subnet. Then we will calculate the network ID of second subnet. 64 plus 0 is how much, guys? 64 plus 0 is how much?
64.
64. This is the network ID of the second subnet. 64 plus 64 is how much? 128, right?
28.
The network ID of the third subnet. 64 plus 128, it is 192. So we have calculated the network IDs, right? Now let us calculate the broadcast ID. So guys, broadcast ID, it is the
-1.
very good, -1. It is the previous IP address of the next network ID, or 64 minus 1 is how much? 63.
63.
Okay, now what is the broadcast ID of the second subnet?
120 minus 60.
123, 127.
127. And it is 191, 192 minus 1, 191. And guys, always
55.
very good. The last broadcast ID will be 255. So these are the 4 different subnets now, and they will not communicate with each other if you use this subnet mask. Okay, we will see how it works also. Now, let us write the ranges. Okay, 192.168.1.0 to 63. Then 64, 192.168.1.64 to 127. Then 128 to 191. Then 192 to 255. So we have got these 4 subnets. 1, 2, 3, 4, and each subnet will get 64 IP addresses, 0 to 63. Okay, it is the last IP address is 63. How you will get 64 IPs here? Including 0, right?
0 to 0, including 0.
Including 0. Now, guys, what is the first valid IP address? What is the
62.
first valid IP address of the first subnet?
192, 168, 1.1.
1.
1.1. Very good. This is the first valid IP address. And what is the last valid IP address of the first subnet?
62.
And what about the third subnet? What is the first valid IP address of the third subnet?
29.
29. And the last valid IP address?
190.
190. And guys, remember, the first valid IP address you should always assign to the router. Then from the second valid IP addresses, they will be assigned to the other devices, to the other end devices like PCs, servers, the printers, etc. Okay. So now, guys, so this is how we do the subnetting using the manual method. Okay, so you will follow the 5 steps to do the manual subnetting, and we have got 4 subnets with 40 requirement, and we have one shortcut method as well. We will use the subnetting calculator. Okay, you will visit this website. Let me show you. So manual subnetting we have seen. To see the logic. Okay, what is the logic behind the subnetting? Okay, you will visit this website, so you can translate it. Then, guys, here you will provide the network here. Let us say we need 192 dot 192.168.1.0 network, and we need to provide the subnet mask. So what is the default subnet mask of class C? 255.255.255.0, guys, but it will not take the default subnet mask 255.255.255.0. It will take the slash value. If you see, it is saying that you need to provide the slash value. So how will you get the slash value? So guys, in 255, if you convert 255 into binary numbers, how many ones you will get?
8.
8. Then 255, how many ones you will get?
8.
255, 8. 8 plus 8, 16. 16 plus 8, you will get slash 24. So we need to provide the slash value here. So let us provide the slash value. Slash 24. And we need to select, okay, this one, host per network. Then we'll click calculate. And you will go at the bottom here to see the calculations. Okay, if you don't see anything here, let us calculate it one more time. What is the problem? Now you can use this PDF also. Okay, if you're not getting any output on the same page, you can see the PDF also in this PDF. Okay, so what we have done here, just 1 second, guys. /24, we need host per subnet. We need how many hosts? 40 hosts. Okay, if you remember this requirement, we need 40 hosts. So we forgot to mention the host here, number of hosts, 40. Now let us calculate it. Okay, you can see, you will get the same answer here. So guys, if you see the same answer using the shortcut method, this automatic method here, the network ID, we are having 4 different subnets, 1.0, 64, 128, and 192. This is the broadcast ID, 63, 127, 191, and 255. And these are the first valid IP address and the last valid IP address. So this is how you perform the subnetting using the calculator. Alright guys, so again you will use the same methods, same steps. Let us do the shortcut method. Let us use the shortcut method here. Okay, let us say this time our requirement is 100 here. Okay, 100 means we can go with class C, and let us again go to the calculator. We'll translate it. Okay, let us say we need 192.168.1.0 network. You need to specify any network here. And again, the default subnet mask is 255.255.255. So the slash value will be 24. Okay, we need host per subnet, and we need how many IPs? We need 100 IPs. So let us see if it is displaying the output or not on the same page. So ignore, okay, all the other calculations. It is doing the it is explaining the calculations we have just seen with different method. And you can see network ID, broadcast ID 0 and 128, 0, 128, and the broadcast IDs are 127 and 255. Okay, now let us see the third example. Let us say we need 30 IPs. Again, 192.168.1.0, and we need host per subnet, and we need 30 host. Okay, guys, so it is making your task very simple here. And if you do not get the subnets on the same page, you can open the PDF 1.0. All right, you can open the PDF also. So you will get all the subnets. So you will get 8 subnets here from 0 to 7, and these are the network IDs, these are the broadcast IDs, and these are the first and last IP addresses. Okay, now guys, let us try to understand how it works. Okay, as we have discussed that if you do the subnetting, the different networks will not communicate with each other. Subnets will not communicate with each other. So how the computer will know that 2 IP addresses belong to same network and it has to make them communicate, and the two IP addresses are from different networks, so they should not communicate with each other. How we should know that the IPs are in the same network or different network? Let us try to understand. So guys, we'll take this example, two IP addresses. Let us say we are having two IP addresses and we'll try to know whether these two IP addresses are in the same network or different network. So the IP addresses are 192.168.1.10 and 1.155, and these are their subnet mask 255.255.255.0. So it is very important to have the subnet mask. As I told you, subnet mask plays a very important role. Okay. So to do the subnetting, to tell the computer that whether the two IPs from the same network or different network, subnet mask is very important. So we'll convert this default subnet mask into binary subnet mask 255.8.1, 255.8.1, 255.8.1, and 0 will be 8 zeros. After that, how many zeros we have, guys, in this subnet mask? In the default subnet mask, how many zeros are there? 8. Okay, 8 means how many IPs you will get? 2 power 8 IPs you will get, which means you will get 256 IP addresses with this subnet mask. Okay, and the network range will be from 0 to 255, then only you will get 256 IP addresses here. Now, both these networks, both the IPs 1.10 and 1.50, they are falling between 0 and 255, which means both the IPs are in the same network and they will communicate with each other. So we have verified using the default subnet mask. Let us say we have done the subnetting. After doing the subnetting, we will get a different subnet mask. And let us say we have done the subnetting and this is the default subnet mask. The IP addresses are same, 1.10 and 1.155, but this time the subnet mask is changed. So the subnet mask is 255.255.255.128, and we will convert this decimal subnet mask into binary subnet mask 255.8.1, 255.8.1, 255.8.1, and 128 will be 1 and 7 zeros. And how many zeros we have? We have 7 zeros. 2 power 7 means how many IPs we will get? 128. How many networks we will get? What is the formula to calculate the subnet? 2 power n. How many bits are converted? How many ones are there in the host portion?
1.
1, which means we will get 2 power 1 network subnets here. 2 power 1 means we will get 2 subnets. Okay, and let us say the first subnet is 192.1, the network ID of the first subnet is 192.168.1.0 and 0 plus 128, 128. So we have got two network IDs. Now let us calculate the broadcast IDs. 128 minus 1, 127. Okay, this is the first subnet, and always the last net broadcast ID will be 255. All right. Now let us see. Okay, where is this 10 falling? 10 is falling in the first subnet, 0 to 127. And where is this 155 falling? It is falling in the second subnet. All right. So both the IPs after doing the subnetting are in different subnets. They are not in the same subnet. Okay. Instead of, okay, let us say you have done the subnetting, but instead of using this default, the new subnet mask, you are using the default subnet mask, so they will communicate with each other. So it plays a very important role. Remember this point. Okay, let us take another example. Let us say we are having two IPs, 1.10 and 1.132, and their subnet mask is like 255.255.255.224. Again, we will convert this 255 into 8 ones, 255, 8 ones, 255, 8 ones, 224. It will be 3 ones and 5 zeros. So we are having 5 zeros here. So 2 power 5 means we'll get 32 IPs in each subnet. But how many subnets we will get? What is the formula to get the subnets? 2 power n. 2 power n means how many bits are converted here?
3 bits.
3. 2 power 3 means we'll get how many subnets, guys? 8 subnets. So the first network ID is 192.168.1.0, and you will keep add 32. Okay, 0 plus 32, 32, 32 plus 32, 64, 64 plus 9, 32, 96, 128, 160, 192, 224. We have got 1, 2, 3, 4, 5, 6, 7, 8 subnets, and these are the broadcast IDs. And now let us see where is this 1.10 is falling. In which network 1.10 is falling, guys?
First network.
Very
First.
good. First subnet. And what about 132?
Second. That's fifth.
Fifth, right? So they are in the same network or different networks?
Okay.
So how it was decided whether they are in the same network or different network? Using the subnet mask.
Subnets.
So guys, instead of using this default subnet mask or the subnet mask, if we use the default subnet mask, what will happen? Both the networks, they will fall under the same network and they will start communicating with each other. Clear?
Yes.
Clear, guys? Any doubt? Mahmoud,
Yes.
Zamran, Salman, any
No.
doubt? Just 1 second. Okay. Now, let us quickly see the class B FLSM example. Now, let us say our requirement is 1000 host. So we cannot go with class class C. In class C, you will get only 256 IP addresses, but we need 1000 IP addresses. So let us select class B.
1002 power 10. It's mean to network will be 20 20/20.
Let us see. Let us verify. All right. Now, so again, we were not going to do the manual calculations. Okay, we will use the calculator, subnet calculator here. So we'll go to this website and we'll use in this network, 172.16.0.0, and we'll provide we'll tell we need 1000 hosts. One 172.16.0.0. And guys, what will be the slash value here? What will be the subnet mask?
16.
/16. We need host per subnet. You will select the second option. And we need how many hosts?
1000.
1000. Let us open the PDF. Now guys, if you see, we will get these many networks. Imagine we are doing this manually. So we'll get 64 subnets, guys. Okay, and these are the network IDs. The first column is for the network IDs. The last column is for broadcast ID. This is the first valid IP address, and this is the last valid IP address. Okay, and let us say this time we need 4000 IP addresses. So let us go with class B only. So you will get these many addresses from 0 to 15, means 16 subnets we will get. So this will be the network IDs, and these are the network IDs, broadcast ID, first and last IP addresses. Then class A example here. So 16,000 is the requirement. You can go with class B. We have seen the class B examples. Let us take the class A example for 16,000 hosts. 16,000 we can go with class B and class A also. Let us see class A. So 8, and we select class A. Let us say 10.0.0.0. And how many IPs we need? 16,000, right?
/20.
All right. So guys, if you see 200 subnets you need to calculate, and the subnet mask, it will be like 255.255.255.192.0. This will be the subnet mask for all the subnets. Let us close these tabs and let us go to the slides. Okay, so you can use, okay, you know how to use it, or you can try for 32,000 host also. Okay, and slash value and subnet mask. So guys, we have seen, okay, instead of, okay, it was not asking for the subnet mask, the calculator was asking the value in slash. Okay, so what does it mean by slash value? Let us quickly try to understand. In this example, if you see, we are having some PCs, these PCs are having some IP addresses configured with slash value, slash 27, slash 28, slash 21. Okay, so we have already discussed, okay, how we have how to calculate the slash value. So slash value, let us say we are having the subnet mask 255.255.255.0. So instead of writing this subnet mask, we can write the slash value. How to calculate the slash value? 8 ones, 255, 8 ones, 255, 8 ones, 255, 8 ones. 8 plus 8, 16, 16 plus 8, you will get slash 24. So guys, this slash 24, it is the alternate way to write the subnet mask. So instead of writing the subnet mask, you can provide the slash value also. But what is the use? If you already have the subnet mask, why to have the slash value? Let us try to understand. So guys, this slash value is used to save the space on your documents. Let us say you are doing some documentation. In the documentation, you will draw your network and you will provide the IP addresses. Then you need to provide the subnet mask also in the same document. So let us say the IP address is 192.168.1.1 and the subnet mask is 255.255.255.0, and you can see it is taking some space here. So in documents, we need to save the space. So instead of writing this big subnet mask, what we can do, we can write the slash value, slash 24. So is it saving the space or not? Guys, is this slash value saving the space or not? It is saving, right? And remember the terminology. When you add the slash value, okay, to any network, let us say you are using the network 192.168.1.0 network, and instead of writing the subnet mask, you are providing the slash value 24, and this term, the term will be referred to as cider block. Clear, guys? What does it known as? When you add the slash value to any network, what does it known as? Cider block. All right. Remember the terminology, guys, and if you want, you can write it down also. So let us see, okay, how to convert. We are having this 255.254.0.0. What do you say, the subnet mask, and we need to convert the subnet mask into the slash value. So 255, 8 ones, 254, you will get 7 ones. Okay, if you see 254, we are getting 7 ones here. 8 plus 7. Okay, what is the slash value?
15.
Slash 15. Okay, let us take another example. 255.255.240.0. So 255, 8 ones, 255, 8 ones, 240. We will get 4 ones. 8 plus 8, 16, 16 plus 8, slash 20. Okay, this is how you will calculate. And guys, you should know vice versa also. So we have seen how to convert the subnet mask into slash value, Let us see few examples to convert the subnet mask, sorry, the slash value into subnet mask. So let us say we are having the slash value of 18, slash 18. How to convert this slash 18 into subnet mask? So guys, how many maximum ones we can have in each portion?
8.
8. Okay.
8.
8. Then we will add 8 in the second portion. 8 plus 8, 16. How many ones are remaining for 18?
2.
2. So 8 ones means 255, 8 ones 255, 2 ones and 6 zeros. So 2 ones and 6 zeros, it will be 192.0. Let us take another example, then we'll move forward. Let us say we are having the slash value 15. So maximum 8 ones we can write in each portion. So 8 ones. And how many ones are remaining for 15? 7. So 8 plus 7, 15. So 8 means 255, 7 ones means 254.0.0. This is how you will convert the slash value into subnet mask. Clear guys? Any doubt, any confusion till now?